how does this relationship actually start making or bringing AI within reach of the commercial world? Kurt, why don't we start with you?
And that's exactly where this reference architecture comes in, right? So a customer doesn't need to start from scratch. They have a design now that allows them to quickly implement AI. It's something that's really easily deployable. We've fully integrated this solution. DDN has made changes to our parallel file system appliance to integrate directly within the DGX1 environment. Makes that even easier to deploy from there and extract the maximum performance out of this without having to run around and tune a bunch of knobs, change a bunch of settings. It's really going to work out of the box.
And NVIDIA's done more than just the DGX1. It's more than hardware. You've done a lot of optimization of different AI toolkits, et cetera. Talk a little bit about that, Darren.
Yeah, so, talking about the example I used, researchers in the past with HPC, what we have today are data scientists. Data scientists understand PyTorch, they understand TensorFlow, they understand the frameworks. They don't want to understand the underlying file system, networking, RDMA, InfiniBand, any of that. They just want to be able to come in, run their TensorFlow, get the data, get the results, and just churn that, keep churning that, whether it's a single GPU or 9 DGXs or as many DGXs as you want. So this solution helps bring that to customers much easier so those data scientists don't have to be system administrators.
So a reference architecture that makes things easier, but that's more than just for some of these commercial things. It's also the overall ecosystem, new application providers, application developers. How is this going to impact the aggregate ecosystem that's growing up around the need to do AI-related outcomes?
Well, I think one point that Darren was getting to there, and one of the big effects is also as these ecosystems reach a point where they're going to need to scale, right? There's somewhere where DDN has tons of experience, right? So many customers are starting off with smaller data sets. They still need the performance. A parallel file system in that case is going to deliver that performance, but then also as they grow, right, going from 1 GPU to 9 DGXs is going to be an incredible amount of both performance scalability that they're going to need from their I/O, as well as probably capacity scalability. And that's another thing that we've made easy with A3i, is being able to scale that environment seamlessly within a single namespace so that people don't have to deal with a lot of, again, tuning and turning of knobs to make this stuff work really well and drive those outcomes that they need as they're successful, right? So in the end, it is the application that's most important to both of us, right? It's not the infrastructure. Exactly. It's making the discoveries faster. It's processing information out in the field faster. It's doing analysis of the MRI faster. It's, helping the doctors, helping the anybody who's using this to really make faster decisions, better decisions.
Exactly. And just to add to that, in automotive industry, you have data sets that are from 50 to 500 petabytes, and you need access to all that data all the time because you're constantly training and retraining to create better models, to create better autonomous vehicles. And you need the performance to do that. DDN helps bring that to bear, and with this reference architecture, simplifies it. So you get the value add of NVIDIA GPUs, plus its ecosystem of software, plus DDN, it's a match made in heaven.